Hi everyone, my name is Mohit Sarveiya. I'm a Google developer expert in Android and Kotlin, and in this presentation, I'm going to share with you how state flows and shared flows work. So what I'm going to share with you is how to set them up, how do you use them, emit events to them. You may also be using a broadcast channel, which was introduced prior to shared flows, state and shared flows to emit events, broadcast events, and I'll share with you how to transition from a broadcast channel to what's there right now, shared flows. I'll also go over different ways to convert code streams to shared flows, different sharing policies that exist, and lastly, we'll talk about the scenario where you may have a really fast consumer, and how do you handle throttling, how do you handle buffer overflow, what are the different strategies for being able to handle that. So let's start with the most simplest concept of what is a cold flow and a hot flow. So a cold stream is a stream that says here's a flow that triggers the same code every time it is collected. And let me share with you an example of what that looks like. So here is a very simple flow that emits, three items, three numbers, and then it increments it in the map. So suppose I were to collect from this flow, and as soon as I collect from it, what happens? Well, the flow starts to emit these values, and it goes through the operators that you apply. Like in this case, it's just a map, and then it will give you the result. Now, if you had a second collector, if you were to collect it again, it will do the same thing. It will run the flow again from the top and emit the items one, two, and three, and then go through your operators and then give you the same result. So every time that you collect from it, the flow is triggered every time. The producer is triggered every time from the top. So that's the characteristic of a cold flow. What is a hot flow? It's a flow that's active independence of the presence of collectors. So it's active in memory, and it could start without even having any collectors at all. So, and every time that you collect from it, it doesn't, trigger the code, the producer code every time. So there are two ways to be able to model, hot streams using state flows and shared flows, and I'll show you both of them. So let's start with what is a state flow. As the name suggests, it's really good for modeling state. And a good use case is in the world of Android, where you may want to create a stream from your view model to your view. And the stream is basically states, different types of states that you may want your view to render. And how do you set that up? So how do you set up the state, and what could it be? The state could be some form of UI state, for example. This is a sealed class, and in there I could have a successful state, which gives you the view some data. You could also have an error state, which shows for displaying some error message on the UI. So suppose you had a stream which gave you this UI states. So the way you set up a state flow, you could use this constructor called mutable state flow. And inside of this, in the constructor, what you have to provide with a mutable state flow is a default value. That's very important. You could also provide a null value in there and make the UI state nullable if you want. So the way you emit to this UI state is similar to the flow, to the normal flows. You could call an emit method on it and give it, whatever you want to emit to it. You could also do UI state.value and specify whatever value that you want. So stateflow internally caches the most recent thing that you send to it, and you could update it by using this field called value. So in order to listen to this stateflow is very similar to regular flows. You just call the collect method, and every time you call the collect method, every time there's a subscriber, each subscriber gets the latest value. So that was emitted. Most recently, that value that was emitted. So suppose that I were to emit multiple times back to back, like a success and error, what will my subscribers get? They won't get the UI state.success. They will get the most recent emission of error. So it has this built-in idea, built-in thing of this doing being able to distinct, being able to conflate, sorry, not distinct, conflate. So it has this conflation behavior, these state flows. So when if I were to collect from my subscriber is going to get the error state. So when you're building UIs, what you could do is that you could combine multiple state flows together that represent different states and combine them, expose some state to the view. So another way to be able to model this on Android is to use live data. And live data and state flow have differences. And the two key differences is one, that in state flow, as you saw, you have to specify a state value. And the state value, you don't have to specify it in a live data when you use it. The other part that's distinct is that you have to specify basically that when your view goes into a life cycle of a stop state, it doesn't really unsubscribe from the state flow. You have that behavior in live data. And in order to get that same behavior with state flow, you could use a lifecycle method called repeat on lifecycle, I believe. So these are the differences between these two constructs. So that's basically a little bit about the basics of state flows and how to, update it and set it up. And you could also convert, regular flows to a state flow using state in. So now let's look at, really my shared flows and all the different things. So shared flows have a lot more features than state flows, like the ability to replay emissions, the ability to buffer emissions, etc. So let's look at how to set them up. So with the shared flow, you could set it up where you have multiple consumers. And just like with the state flow, it's used for broadcasting events. So that event could be anything that you want. So I could broadcast event to n number of consumers. I could also replay the most recently broadcasted events, and how many of them I could specify to replay. So I could also, buffer emissions, like everything that I send, I could specify a cache then which it gets stored before emitting to any of the consumers. So let's look at how to set it up. So this is a constructor for setting up a shared flow. And I'm going to say that this shared flow emits a string. And in the constructor, I don't have to specify a default value like I did with the state flow. So here, this is a shared flow. So I'll show you later on, there are, in the constructor here, you could set up, I'll show you later on how to set up a replay count, buffering strategy. There are a lot more things that you could configure in this constructor. This is the most basic, simple usage. So I have here I'm launching a coroutine that's listening to this flow. So you always want to have separate coroutines for the one coroutine which sends things to this shared flow, another coroutine which basically reads from it, consumers. So have a coroutine which is ready and listening to it right now. Nothing has been emitted to this flow. As soon as I emit something, event of one, my consumers, in this case only have one, it will receive what I emit to it. So this is the most basic, simple usage of a shared flow. So there is a scenario, suppose, where, I may have a consumer that basically, listens to this flow after some particular delay, not really immediately. I may have a consumer that comes in at a later point. What happens then? So in this example, so now after this delay, this coroutine, I'm listening to the flow. So as you can see here, that I listen to the flow after this emission happens, not before it. And so in this case, the question is, will I receive the value that was sent? So when you start to collect from it after this delay, you'll see that you don't get any value back. And why is that? The reason why is that the way the shared flow is set up right now, the replay count is 0. It won't replay anything that was most recently sent. So in order to fix that, you could set up a replay count like this of 1. So you go replay of 1, the most recent 1 value could be 2 or 3. And then you'll see you got an event of 1 emission. So that's the purpose of replay count that you could set up. So the other thing about that you could configure query is how many subscribers do I have currently? What is my subscription count? So flow.subscription count gives me a state flow. And I could, just as you saw previously, because it's a state flow, I could query using dot value. So right now I have one subscriber to this shared flow. So shared flow, the other thing that's important to note here is that a shared flow doesn't complete normally, and what does that mean? So let's look at a cold flow like we saw before. Here's a regular flow. This is not a shared flow or a state flow. And after the items get emitted, 1, 2, and 3, it will ultimately call the onCompletion event. It will call it because the flow has completed emitting everything, and we call this that the flow completed normally. It didn't complete because of some exception or anything like that. All the items were emitted. That won't happen with a shared flow right here. A shared flow could complete, but it could complete for different reasons. So one reason is that the job in which you are collecting from this flow. So example, I have a job here for this coroutine and this launch block, and I'm canceling the job. And when I cancel the job, you'll see that the onCompletion handler onCompletion gets called, the flow completes, in this case, exceptionally. So that's an important point to know. So we looked at some of the basics of how to set up a shared flow, how to replay something, how to emit something, and how cancellation works. So the next part to look at is, in using this, how do you migrate to it? So let's look at how it compares to what was there previously, which is a broadcast channel. And a broadcast channel, was used to propagate events, and it provided an API to send things to it, to close it. How does it compare to a shared flow? So we'll compare both of these constructs and look at these 4 different things. One is that a shared flow doesn't have the same APIs as a broadcast channel to send and to receive. It's much easier, and that's why it was introduced, to make it much easier. So when you look at, here's an example of a broadcast channel, and this broadcast channel has about, it has a capacity, and 10 specifies a capacity of how big this is an array broadcast channel. And I could send things to it, and I could, I could also receive and read from it. As you know, with, channels, there's channel.receive that you could use. There is also API like channel.try send. So you could close the channel. So in the world of immutable shared flow, they have something equivalent to that, which is an emit call or a try emit call. And the difference between that is that emit is suspending, just like channel.send, and a try emit returns a Boolean, basically, whether the emission was successful or not. So with the immutable shared flow, it's much easier. There's no close, and the API is much more easier to use. And the other part is that the replays, and the replay, as I showed you, broadcast channels don't have the ability to replay something, whereas a mutable shared flow does. You could specify here replay, how many latest items to do so. The other part, which is different, that both of them actually have this feature, is that you could specify a capacity. So with both buffer and share, you could specify how big the cache will be. So you could specify here that my capacity is that I could store 10 things in there. As soon as I get to 10, the send call will suspend until there is space in the buffer. So similar to that, with a mutable shared flow, you could specify the buffer size. Where things get interesting here, because when you specify a replay, that in itself is also a buffer size. So you also have to take into account both of these things. So on top of that, if you want extra capacity, there's a param to do so here. To reiterate, when you create a shared flow without specifying any of these things, the replay is 0, extra buffer capacity is 0. One of the great things that I'll show you in a couple of minutes is that you can specify different strategies to be able to lay eviction strategies for your buffer when it overflows, right? And I'll show you later that you cannot, I don't think you can do that with broadcast channel, but you can do it in mutable shared flows. So those are the two things that both of these things have. And the other part is that when you use a broadcast channel, it's very important to ensure it closes, and you don't do that where there isn't an equivalent of that with mutable shared flows. So those are this is how both of these things compare. So how do you map basically your code that uses this broadcast channel to shared flow? So when you specify a broadcast channel like this, what the capacity matches the extra buffer capacity. The other thing you could specify here is a replay count, which is good to specify as 0, and then this extra buffer capacity. So this is a mapping that you would want to do. And the other mapping that you want to do in your code where you communicate with this channel is this. So wherever you have send, you could change that to an emit on the flow. And then you could map the try send to a try emit if you want. Important point again is that a try emit is try send or not suspending. So that's how you go from, if you have legacy code and using a broadcast channel, to use the shared flow. And that's how those compare. So next thing that I want to talk about is converting regular flows to how do you share it in basically a shared flow. What are the different ways to do that? And there are different strategies that allow you to specify how control the emissions of it, whether it's eager, whether it's lazy, whether etc. And let's look at each of these different strategies. So I want to be able to convert like a cold flow into a hot flow. And there are different ways to do that, these different strategies that you could share with using. And let's start with while subscribed and how that works and examples of that. So suppose I had some flow, and the way that you convert it, so this here is a regular flow. It's not really a shared flow or a state flow or anything. It's a regular flow, and then if you want to convert it to a shared flow, you could use .share in, and then in the params of this method, first you have to specify the scope. So internally, this code, right, it basically uses this scope to launch a coroutine to be able to collect from this flow that you're using and emit those items to a shared flow that it creates for you. And I could specify my replay count, how many I want to replay. And lastly, I want to specify what the behavior is in terms of how it starts to emit items. And I'll go through what while subscribed means. So when you run this, what this returns is a shared flow instance that you can now use to listen to things, to emit, to use it to emit things. So while subscribed has two different properties. One is that It's active as long as the external scope is alive, and it remains as long as remains active as long as you have subscribers, collectors listening to it. So let's break down both of these things one by one. It's active as long as the external scope is alive. What do I mean by that? So suppose I have a subscriber that's listening to this shared flow, and I take the external scope that I passed into the share in method, and suppose I canceled it. When I canceled it, basically, the on completion block will be called for each of the collectors, basically. And the collectors, like, they will finish, they will complete exceptionally. So it's alive as long as the external scope is alive. And in this case, I'm canceling it. And the second property is that it remains as long as there are collectors. So for example, suppose you had a flow like this, and I added an on completion block before the share in. And when I suppose I had a subscriber, so I'm creating a coroutine, and I have shared flow dot on completion, and I collect from it. And then I have a reference to his job. So when I cancel the job, you'll see is that the subscriber basically, it completes. And then you have also the on completion block of the producer is also called. So suppose you had two basically subscribers, two references to the job, and I cancel only one of them. It will not call the on completion block yet, because you still have one subscription count, and the flow will remain active. So those are the two properties, with using while subscribe that to be aware of. The other two ways to specify, how your flow starts is using eagerly and lazily. So eagerly, what it does is that, as the name says, is that, like, you create you use share in operator, and you create your shared flow. It will basically start right at that point, regardless of whether there are collectors. So suppose I have specified here eagerly, and when I do this, basically, I have here specified on start, and I log it out. And then you'll have specified eagerly. Right now, I don't have any subscribers to this flow. So it will, even though I don't have any collectors, it will basically start, and you'll see that on start basically gets logged out. So that's behavior using sharing started eagerly. That's not the same behavior with while subscribed. So the other thing is that it never stops. So if I were to cancel the external scope that I use for the share in, you'll see that on completion, sorry, there's a typo, it should be called on completion never gets called. So start producer eagerly and never stop. That's the behavior of this. The other one is lazily. And as the name suggests, what that means is that it won't start immediately. It will wait until it has at least one subscriber. And this is what it does. Starts sharing after the first subscriber appears and never stop. So when I specify lazily like this, and then I'm going to specify on start, and the only time that will get logged is when it has a collector. So over here I have a collector, and you'll see that it will log on start. And it also never completes, just like, eagerly. So if I were to cancel the external scope, you'll see that the on completion won't get called. So that's the example for that, lazily, is that it will start sharing, and it will start basically when the first subscriber appears and never stop. Well, this is a good summary of the behavior of these different things, and this is good to know, and good to know which one to use depending on your use case. So the other thing that I want to talk about, the last thing, is buffer overflow strategies. And so what is this for? And as I spoke about earlier, is that when you look at a shared flow, you could specify, as you saw, some capacity and how big it is. And basically, you could have a scenario where you have a producer that's generating events really, really fast, but the consumer is slow. The consumer is slow to consume it. and they may be listening to events and have some delay. And in that case, you could have a buffer overflow. And what do you do in that case? How could you handle different ways to handle that? So you could have send one item, second item, and then third item. Now the buffer is full. So there are three different ways to handle that. One way is to suspend. The other ways, two ways, are to drop the oldest and the latest value in the buffer. So what suspend does is that it will suspend basically the producer until the consumers have consumed, the events that are in the buffer, until there is space in there. So the default behavior of a buffer overflow is a suspend. So I have specified it here, but it does it for you. This is the default value in the mutable shared flow constructor. So what I have here is that I don't have a replay count here. Replay count is 0, but I have extra buffer capacity of 2, and the buffer on buffer overflow is suspend. So when I send, two items, when I attempt to send the third, it will, suspend until until the consumers have, consumed the events. So the next basically strategy are very simple to understand. There are 2 unit tests that are in the coroutines library that also give you a good example of it in working, which is drop oldest and drop latest. And what it will do is that it will drop the oldest value in the buffer, whatever the oldest value that you had sent to it, and drop latest will drop the most recent value that was sent. So which one you use in 3 of these depends on your use case that you wanted to use it for. So these are the things that we talked about. These are the basics of using shared state and shared flows. I talked a lot about shared flows, and it has more functionality, and hope that was helpful. And I wrote a blog post which has also unit test, and which has more information and everything I spoke about in written form. And you can go to my website, codingwithmohit.com, and the title of my blog post, Learning State and Shared Flows with Unit Tests. And I show you how to different use cases for writing unit tests and with shared flows. And I want to say thank you for having me on Under Worldwide, this event. If you have any questions, you can message me on Twitter or give me a message. I'll help you out. And thank you. I hope this was helpful to you.
Okay, awesome. Let's see. So if anybody has questions, please post them in the Q&A. Thank you, Mohit, for another wonderful presentation.